Alrighty, let's see what we got today. Looks to be a medium. Alright, reschedule meetings for maximum free time, part 1. You're given an integer event time denoting the duration of event where the event occurs from time 0 to time event t event time. Okay, so it's 0 to end time. You're also given two integer arrays, start time, end time, each of length n. These represent the start and end time of non-overlapping meetings. Okay. And non-overlapping where the ith meeting occurs at a start time at I, end time at I. Okay. Sometimes they give it in a single array that has elements that are two element arrays, but here they're just using separate arrays for the start values and end values. You can reschedule at most k meetings by moving the start time while maintaining the same duration to maximize the longest continuous period of free time during the event. To maximize the longest period of free time during the event. The relative order of all the meetings should stay the same and they should remain non-overlapping. Interesting. Return the maximum number of free time available after rearrangement. Okay, so start time 1 to 3, end time 2 to 4. So start is 1 and 3, end time is 2 and 5. So like this is 1 to 2, this is 3 to 5. I wonder why they give it in this fashion rather than in the other fashion like from yesterday. This is slightly more difficult to parse. 1 to 2, 3 to 5, so maybe move the 3 to 5 to be 2 to 4. So 1 to 2, 2 to 4. Reschedule the meetings at 1 to 2 to 2 to 3, leaving no meetings between 0 and 2. Oh, I see. If you move the 3 to 5 to be at the very end to start after the 2, then you'd only have one block of free, either between 0 and 1 or 4 and 5, since the 0 is always the start, not the 1. So it's preferable to just move the 1, 2 to become 2, 3, and you have 0 to 2 be free. Okay. So here, 0, 1, 2, 4, 6, 9, k is 1, so it would be identical if you move the 2, 4 to be 1, 3, or you move the 2, 4 to be 7, 9. You're going to have a block that is 6 free. If you move this up, then the block that's 6 free is between 3 and 9. If you move this back, the block that's free is between 7 and 1. Interesting. Interesting. So, I mean, I think does it say that the start time is always going to be increasing? Start time of I is less than end time of I. So I don't think this is going to be strictly increasing in terms of start time. So I would generally want to reorder it so that I can look at the start times and end times in the fashion that they'd be ordered in. I could also just create a separate array of tuples that are start time, comma, end time. That might be a little simpler to deal with. It takes more memory, but like this is kind of bothersome to have to reorder it. I have to reorder it by key, where the key is the index. Okay. All right, I'm going to create some tuples. So I'll say so I'll say blocks is going to be an array, and I'll say for every index in the range of n, where n is the length of the number of events, which could be either the array start time or the array end time. Blocks dot append a tuple that is the start time at this index, comma, the end time at this index. And then I'll go ahead and sort that. Again, the alternative, I need to print this out to make sure that it works. Alternative to this approach would be I would sort the start time and end time using the index of the element as the how would I do that actually? Actually, could I just sort the start time and end time independently because they're non-overlapping, right? Like, they're non-overlapping. Yeah, okay, I think maybe I don't need this. Even though this probably gave me what I was, maybe this is easier still. Yeah, it's probably not worth the extra space to create another array. Let's go ahead and comment this out for now. Start time dot sort, end time dot sort. Yeah, these are all increasing. The test cases are all increasing, but it's not necessarily the case that needs to be increasing. It just says that they're non-overlap. Okay, anyways. What to do from here? So if I take one of the examples, let's say I take the first example. If I tried moving, so I have k things I can move. And in general, I think in general what would happen would be that what would happen? If you can move one thing in the whole array, and let's say there's like a million time blocks, you can shuffle around basically one block, then what you're basically getting is the space between the space that is on either side of the block that you're moving is going to be basically concentrated. So either if you move here, this white space is going to move over here, and it's going to combine with this white space, and you still get 6. 1 plus 5, or you move this block back and you combine this 1 with this 5, where this 5 kind of shuffles over, you still get 6. So a single block movement is going to it's going to combine the white space that is on either side of it. Now you can get the benefit. Okay, so this thing moving would combine the 1 and 1 here and get 2. This thing moving would combine the 1 and 0 here and get 1. What happens in the case where it's like adjacent already? So if you had, let's say, I'll say there's a block and there's a space. And let's say this is block A, block B, and let's say there's some space, block C. So if you don't need to move, I think I think I just treat 0 as the stuff that's around adjacent blocks. So this is, I can shuffle this around, but currently it gets me 0 when I shuffle this around. I shuffle this around, and this gets me maybe at most 3. And I can shuffle this around, and I can get individually, this is 5. But if I shuffle both things around, so ideally if I had one shuffle, I'd move this in here and get 5. But let's say I had 2 shuffles. If I had 2 shuffles, then I would move the B to the front and then the C to the front. Let me double check here. What's going on? You reschedule at most K meetings by moving their start time while maintaining the same duration. Okay, yeah. If I move this block instead of, and if I move these 2 blocks, normally if I just move this one block, I'd get like 4, combining the 1 and the 3. But then once I have that 4, then moving this block is actually combining 4 and 2, and this gives me 6. So it's not actually, so it's not the issue is moving one block changes the benefit of moving another block, I think. So for instance, moving the block BB gives me 4, moving the block C by itself gives me 5, but moving both blocks together doesn't give me 4 plus 5, which is 9. Because this, I would be double counting this inner block. I think what ends up happening would be the chain of free things. Like this is the sum of these 3 blocks. 3 free time slots. Okay, yeah. It's 3 consecutive time slots for 2 movements, 2 consecutive free time slots for 1 movement. So K would be, I can combine up to kind of K plus 1 consecutive free time blocks. So I just need to calculate which were the free time blocks, and I think I can figure out what the highest sum of K plus 1 consecutive of them are. So, so I guess kind of my guess is my guess hypothesis. My hypothesis is moving K time blocks will result in a single kind of free slot, or I guess a free range, free period. That is the sum of K plus 1 consecutive kind of gaps. The gaps are moving K, I guess I could say this is consecutive time blocks. Well, the first hypothesis is best to use movement on consecutive time blocks to create a free slot in that area. Like it doesn't make sense to move like something in the front to make a block and then something in the back to make a block, because it's better to just have a single block in some zone. And then part B is moving K consecutive time blocks will result in a single free period that is whose size is the sum of K consecutive gaps before, between, after those time blocks. Yeah. Okay, so I'm going to go ahead and figure out what the free time blocks are. So free slots, and I guess the first free slot would be equal to the size. How would I calculate this? I can say make current is at 0, and then I would append for every index in range n, where n is the number of events. I think this would be something like start time of n of this index, or free slots is going to append start time of this index minus the current time, and then the current time is going to equal the end time of this index. So what would happen would be when index is 0, you would look and say, well, 0 is going to be, start time of 0 is going to be 1, and 1 minus 0 is 1. So the first free block is 1, and then it's going to move the time to be the end of that slot, so it's going to be 2. Next loop, index is 1, start time of index 1 is going to be 3, so it's going to be 3 subtracted by the current time of 2, so it's going to be another free slot of 1, and then it moves the time to be 5. And then I'll have one last thing at the very end where I can append free slots, append the last time, which is the event time, minus the current time. And I'll just print out that to make sure it works. Okay, so 110, 110, that's right. This should be 0150. 0150, okay. And then the last one is all zeros, I think. 0 to 1, 1 to 2, yeah, this is all 0, 6 zeros, I think. Okay. Alright, and then I just need to find the highest k plus 1 consecutive. I think at this point it could probably be I think I could probably just do something like prefix sum. Nah, no. I just make an array of k plus 1 consecutive. So I could say, well, I don't even need to make an array. I could probably just do the sum. So answer equals 0. Actually, the answer is going to equal the first k plus 1 free slots. So the sum of free slots from 0 to k plus 1, I want to say. So k is 1, then be 0 to 1, which is incorrect. It needs to be 2, right? K is 1, it needs to be 2 time slots, 2 free slots. So I think it should be k plus 2. And then for each index in the range of Okay. Biobrick. Here. Okay, so for every index in the range, actually I think maybe I'll just do a prefix sum. Prefix sums is going to be the sum of everything up to the nth element. So starting with, let's say, the current sum is 0 for every, actually, maybe I can say the prefix sum starts with 0, and then for every value in my free slots, prefix sums append that value plus the last current sum up to this spot. Prefix sums dot append prefix sums. Okay, so I should probably print out my prefix, my initial free slots to verify the prefix sums. Alright, the sum 0, 0, 1 is 1, 2 is 2, 3 is 2, that's right. 0, 1, 6, 6, that's right. Okay, so this is generally pretty quick in order to find the sum of like the sum between two, like a subarray within it, because I can just do the index, the prefix sum at this index minus prefix sum at the index minus the range of the things I want. So answer equals 0 for every index in range. I think it should be n. I'm kind of doing this on the fly. I think it should be n plus 2 minus k. Feels like that's about right. Answer equals max of answer and prefix sums of index plus k minus prefix sums of index. This might be some off by 1 deals, so let's think about this. So if I'm doing k is 1 and index is 0, it should be prefix sum of 2 minus prefix sum of 0, so it would be k plus 1, index plus 1 plus 1, 0 plus 1 plus 1. I think that's right. And then the upper bound of what I want. So if it's something basic like this, k is 1, the n is 2, it should be from prefix sum of 0, 1, 2, 3. No, so the starting index could be 0 to 2, 1 to 3, 0 to 2, 1 to 3. I think it's n plus 1 minus k. N being 2, plus 1 is 3, minus k is back to 2. Okay. Alrighty. I think inserting the prefix sum probably slowed it down some. I think the free slots is fine. I think, okay, I could probably do this on the fly, right? I can do this on the fly. So every time I appended a free slots, it's going to be, yeah, I could do this on the fly. So when I say on the fly, it means that I have a for loop to do the free slots creation, so calculating all the free slots, all the gaps between time blocks. I have another for loop to do calculating the sums up to the nth time block, and then I have another for loop to do an answer, try and find the sum of the every k plus 1 free time blocks. I can do that on the flies, and I can, in a single loop, determine what the free slots would be for the gap that is between event like I and I plus 1, and then add that to some running total, and then also add that to some running total, and then also compare that with some maximum answer that would increase if the current value is bigger. I could do that. All right, let's try my best here. I think this is the totally fine solution. Decomposes the problem pretty well. But let's go ahead and test my abilities to do the modified stuff. So for every index, I'm going to do this on the fly. Thinking maybe I should do a queue, a deck, double-ended queue, so I can maybe put the latest the latest gap on in the push it onto the end, the queue, and then pop the earliest gap off the queue. Okay, so I think I'm going to track the free slots, gaps between time blocks. Using a double-ended queue. I usually call those decks. I'll call that free deck. It's going to be a double-ended queue. And then it would be something like for every index in range n, maybe I should add the first n minus 1 or the first k free slots. Yeah, I should add the first k free slots. So every index in the first k, I guess the free deck current 0. Okay, so free is going to be start time at index minus current. That's the free time. And then free deck will append that free amount. So if k was 1, then it'd be going to the first, it's going to create the first gap. Okay, I think that's fair. Answer is 0. Actually, answer is going to be the sum of the stuff in my free deck. Yeah, it's going to be the sum of that. Well, I guess I could just done that here and say answer plus equals free. Well, yeah, I guess maybe I should say there's a current sum, which is 0, and maybe this should be current sum. and then for every index afterwards. So from k to, so I think it should go up all the way to n plus 1, or just go up all the way to n. I think it goes up to, it needs to go through the events, right? So unless I add a dummy event at the end. Yeah, maybe I can add a dummy event at the end, actually. So current free is equal to start time index minus current. I think I also need to change the current time to be end time of this index. And I think I want to actually add a dummy event at the end. So how would that work? I think I want to add start time dot append the last start time is going to be event time, I think. Last event time, so that if I do one final loop, it'll be the event time minus that. Yeah. And I also need to add a dummy end time. Append at dummy end time, so let's say this is infinity. Okay, so I think here it could just go to n plus 1. That won't go out of bounds anymore. So free is equal to start time at this index minus the current time. And then I can do free dec dot append this free time, current sum plus equals free time, answer equals max of answer and the current sum. And then I have to pretend that I'm moving to the next time slot, so I pop off the current, pop off from something from the deck with the front end. So current sum minus equals free dec dot pop left. And current time is equal to end time at this index. All right, turn answer. All right. Okay, successfully navigated that transition from kind of a decomposed version of the solution, which I think is something I would understand more readily, to a kind of more, let's say this is kind of a decomposed version, slightly less optimized due to having multiple loops where each loop does a separate component. Here, this is a calculate gaps between event times, and this is B. This one is pre-calculate the sums for the prefix sums, which is sum up from 0 to I. of free slots and see, use prefix sums to find max sum of k plus 1 consecutive free slots. And when you deal with prefix sums, if you take the sum at index I versus the sum at index less than I, then the difference between those sums is the sum of the elements between those two indices. So the prefix sum of 10 minus the prefix sum of 5 is, or let's say prefix sum of 10 minus prefix sum of 7 is going to be the sum of the elements between 10 and 7 with some conditions on which is inclusive and which is not inclusive. Generally it's going to be inclusive of the element at the last index and not inclusive of the element at the starting index, I think. But anyways, so this wasn't really used. And then this is the more optimized version. In single pass, do every component of the second pass of the other version. So kind of calculate what your difference between time slots is, and you can do that for the first k, because the first k doesn't necessarily have enough time slots, so you just do that separately. Separately do calculate the first k gaps, which is like one less than the number that you want. And then this is just a kind of hack to not have an if statement. Hack to deal with ending, because the ending kind of has there's a gap from the end event time to the actual last event end time. So if the last event was ending at 4 and the event time end at 10, then you kind of want to do one more extra gap for 10 minus 4. So that's that, and then this is the main loop. Add, calculate, write the gap, add to queue, update sum and check for the max answer, and update sum, queue, check for max answer, change time, and then remove early gap. Basically the I minus k gap. Which in this case, which is going to be the start queue. Alright, so this was the correct hypothesis. And so summary, this is, I kind of went over it, but in general, need to determine gaps between times. And that was just mimicking what time that you're at to be, like starting at 0, comparing the difference between that and the start time at index I, and then moving your time to be the ending time of that event. Need to determine gaps, times, track sum of gaps with maybe a sum variable, and gaps themselves. So maybe using prefix sum array or queue, and when dealing with ith gap, add to sum, update max. Basically when the sum has k plus 1 gaps within it, and remove the early gap. Again, this depends on using Q. If Q, pop the left side or pop the front of Q. And if using prefix, then just always maintain the correct difference between indices. Time complexity is going to be O of n to do single pass through, actually, sorry, this is going to be O of n log n to sort the times, and O of n to do passes to compute the gaps, the sums, and the best sum. And then space complexity is going to be O of in general, you need to know at least k values for optimized version, which uses the Q. We'll have k values, or roughly k values for gaps between time events. Less optimized version, so that'd be O of k. Less optimized version uses O of n for the prefix sums. And I don't think you can get away with doing less than that.